Welcome to everybody. This is the last series in the Advanced Modeling webinar. This one is titled Workflow Optimization in BIM Bridge Projects. So it's a really interesting topic. I hope you will enjoy it as well. So before I start, my name is Muail and I'm here in Alplan as a BIM Bridge Research Engineer. Before that, I did a postgraduate master's program in BIM. So I have some experience in BIM modeling, in BIM development, as well as some Python development. Besides this BIM, I was also a bridge engineer by training, so I also have experience in that field. So coming to the discussion at hand, which is workflow optimization in BIM bridge projects, are going to have some agendas. We will start with the introduction. So we are going to have a talk regarding the BIM, or also regarding the optimization, what we mean by optimization. Then we will move to the BIM workflow that you can already implement using the Alplan solutions. We will then move to the techniques or workflow optimization. Namely, we will start with the library objects. So I'm going to explain what I mean by library objects, and I'm going to give you here an example of that. We are also going to look into parametric reinforcement, which is a bit exciting topic if you ask me. Then we are going also to look into the visual scripting, so how we can use visual scripting to automate some tasks usually, or we could also even use visual script to create objects or even the model as well. And finally, or lastly, we're going to, in the optimization technique, we are going to look to the attributing. So we're going to see how we can properly, or how we can extend the idea of attributing. So we can extend the flexibility or the usage of the attributing. It's not just about the IFC attributing, so it's way more than that. So we will also try to look into the attributing, which is really a optimization technique if you ask me, in the workflow. And finally, I will also give you some examples that are use cases, so we can also have a look at those, which will of course summarize the whole idea of the presentation. So I'm going to start with the introduction. First, I'll just start with the Alplan Bridge. So by now, some of you are familiar with the Alplan Bridge. So it's a parametric modeling solution. So it allows you to parametrically model your project or your bridge. So everything is parametrically connected. So if you change the axis, all the bridge is also going to move. Or if you also change some of the cross section, it will also change as well. Besides the parametric essence of Alplan Bridge, you also have the phase construction as well. So you could also include that. So you can, as you can see here, you could also include the phase construction. So it gives you additional added value. Moving out of the modeling area, you also have the possibility or the functionality to do the structural analysis. So as you can see, we can do the structural analysis of the same model. This is in the same product as well. And finally, you could also do the code-based design. We have different code-based regulations, so you can use them, and you can use them to design as well. And lastly, in the workflow, we could also do the detailing, the reinforcement, and of course, you could also generate the drawings. So this is kind of a glimpse of the workflow of a bridge, which all could be done using Alplan Bridge. So coming to the topic at hand, which is BIM, I will not try to explain what BIM is, but rather I will just point out some things or some indications to why we need BIM. So I'm going to give you a bigger or a perspective or bigger lens. So one of which is the time perspective. So we use or we implement BIM because of its effectiveness. So we can be more effective in the work, and we can be more efficient because we have different tools to automate. We have different functionalities or techniques that we can implement, so we can be more efficient. So this is the biggest one, if you ask me. So we have the time perspective. But doesn't necessarily mean you are going to submit a product or a project which is a qualityless but in a short span of time. The idea here is it could also be submitted in short span of time, but with a quality full model or project. So the quality could also be kept at even at the higher one. So this is also an added advantage. And the third one, which is like a different one, or you might not have seen, or you might not have observed it, is the creativity. So now with the implementation of BIM, it's really possible to create different types of buildings or constructions, or even in our case, different types of bridges that were not possible before while we were using the 2D CAD authoring or modeling system. So we have also creativity, even also we have parametric design or generative design. All these design techniques were aspired due to BIM. So this is also the reason why you should implement BIM. So these are just some perspectives or bigger lenses to why we use or why we need BIM. So we could also have more reasons, such as the environmental impacts or other reasons. So this is just some lists that I think are relevant to the presentation as well. So the question now is, how can we even benefit from BIM? We already implemented BIM in the office, so we are using it, and we already have some really nice progress. But the idea here is, how can we even squeeze it more so we can even benefit more? So which is the title at hand, how we can optimize our workflow, which was already optimized using BIM. The first, like I said before, was we can apply library objects. So here, I mean, we can store the objects in a library-based system, or this library-based thinking. So instead of recreating the objects or the data or the setting or even the template in the different use case, you will use this object multiple times. So this is the idea of library-based thinking. And the second is, of course, the parametric reinforcement. I know detailing or reinforcing objects or even bridges, it takes some time. It's also tiresome. So applying this parametric reinforcement could improve your workflow as well. We also have the automation, which is the visual script, and we also have the attributing. So these four are a way that we can implement or we can optimize our BIM workflow. It was already optimized when we moved from 2D to even from 3D to BIM. And now the idea is we already have BIM to some extent in the office, but we could also add these workflows that could allow us to optimize our workflow, or in general the benefit. Before I jump to each one and I explain, I will just pause here and I'll just give you the general workflow that we already have for Bridge. So these are the Altplan products or Altplan solutions that we can use in a bridge design. We can start from any of them, but for the explanation purpose, I will start in BIM Plus. So BIM Plus is a collaboration environment. It's in the cloud, so it's based on OpenBIM. So here we have API, which you can access. So it allows you to create or store data or even write from another third-party solutions. Because we have this API, it's open in a sense. So it will allow you to do different additional things. So in our case, at this stage as well, in the bridge design, what we use BIM Plus for is for the land XML or for the axis. So we want to import an axis to our project. So we use BIM Plus to import using land XML. Like I said, BIM Plus, it's a cloud collaboration environment. It's also based on OpenBIM. You can import using different formats. In our case, we're using land XML to import the axis. So after we have this axis, what we do is we send this axis to Altplan Bridge. So I'm saying send or receive in a sense that it might really have to do it, but in a sense because it's one product, so you are just sharing them, updating them. So it's a really useful, user-friendly process. So we send this axis to Altplan Bridge, where I tried to give you an introduction in the beginning. It's a parametric solution, so it allows you to create your bridge parametrically. So you have axes, you have cross-section, you have different components to it. So if you change some of the parameters or the variables, the bridge will also adjust accordingly. So that's what we are referring to, a parametric solution. So here in our case, we have an axis from BIM Plus. Using that axis, we were able to create this bridge. So this is a 4-span precast girder bridge, as you can see. So this was easily created using the axis that I have from the BIM Plus and using the parametric solution of Allplan bridge. So I can easily, if I change the axis, this bridge will also adapt to this new axis. So that's what we mean by parametric as well. And after we have this bridge designed already, what you can do is you could do the structural analysis in Allplan bridge, or you could also send it to BIM Plus. So if you send this analytical model to BIM Plus, like I said, BIM Plus is an open BIM. It's based on open BIM. So you can share this analytical model to a third-party software. So they can do further analysis on this or further computation on this. So that's one way to go. Or you could also do the analytical design as well as the code-based design and analysis in Allplan Bridge. And you can send this model to Allplan, so you can have the geometrical model in Allplan. Where Allplan, it's a BIM solution, so it allows you to alter additional components to your bridge, such as maybe even the reinforcement. And you can also generate the drawing. So that's what Allplan is. So in our case, we have the geometrical model. So what we do is we send this geometrical model to BIM Plus in case we might want to share it with other stakeholders, because BIM Plus is for free, so they can access BIM Plus. Or you could also use BIM Plus and Allplan together when you have a collaborative workflow, collaborative teamwork. So in this case, you could also use it in that way. But of course, you could also export your data, the BIM Bridge data, in IFC formats, or you could also export it in other different formats. Allplan is a partner of the Building Smart, so we follow the OpenBIM standards or the principles attentively. So it's, in a sense, it's open, so you can share it with different vendors, or we could also import different formats which are available in different vendors as well. So this is the BIM workflow. So the idea is how we can optimize this bridge BIM workflow so we can benefit even more. So I will start with the library objectives, which is what I tried to explain before. That is, when I refer here to a library objects, what I'm referring to is I create an object once, an object, or it could also be a setting, it could also be a template or a report or even a legend. So this, we can categorize them as an object. So what we can do is we can create all these objects once, so that we can avoid the repetitive creation of these objects or the repetitive input of data. But the keyword here is that once that I create the object, it should be verified. It should be a proper object. So it doesn't make sense to create just an object. So we have to check it to verify it every time you want to use it. So it loses its essence or its meaning in a sense of time saving. So the idea is create it once, verified data, using already verified data, so you can use it multiple times. So I'm going to give you two examples, one in Allplan Bridge and one in Allplan Engineering. To start with, in Allplan Bridge, that is, so I said Allplan Bridge is a parametric solution. So we have an axis. From that axis, we create also cross sections. So we can combine the cross section and the axis, so to create the 3D model for our bridge. So we need cross sections. So the idea here is that once you already created a cross section that you can use in different projects as well, you export this cross section as a TCL. So you have it here, it's already saved in the project directory. Then you can import this to other projects. So you can import this TCL. So it becomes easier to create cross sections or to import and send cross sections. Or in a formal way, we also have this template idea here as well. So this is a template that's already contains cross sections that are available based on different standards we have for ASHTO or for other standards as well. So you use these cross sections and you can import them to your project. Of course, you could also expand this template, so the cross-section template. So in your office, you can expand it, so you will have more cross-sections. But of course, the idea here is it will be available to all the other projects. So I might be working in one project here. Once I created the cross-section, my colleague on the other office can also use the same cross-section for another project as well. So we're saving time. But the key word here is it should be a verified data. In this case, it should be strongly parameterized section. What I mean here to show you is I have a cross section that I already imported from the template. As you can see, we have different variables or these inputs for this cross section. So it means it's already parameterized. So I can change these different variables. So I'll create a different cross section, or the cross section will be changed according to the use case, but it's still the same cross section. So this is the advantage. I'm using the same cross section, but because it's a parameterized cross section, I can change it or tweak a little with it, and I can come up with a cross section that fits my use case. Of course, if you also move to Allplan Engineering, we also have a library. So in this library, you could add different components. In our case, we need a bridge component. So I'm going to give you a bridge bearing. So even if you look into this project, we need this bearing multiple times across the bridge. So the idea is we should not create it how many times we need it, but we create it once. For example, in this case, we need 6 bearings, but we create it once and we apply them 6 times. And of course, we have to store it properly. So as you can see, we will have the bearing like this. But one thing to notice here is that the bearings, they have different heights in this project, as you can see in the slide. So how we can also address this challenge is to create the component as a parametric as well. So here, as you can see, I have a bearing which has properties or different inputs or variables or parameters, however we like to call it. And I can add a value here, or I can change the value, and you can see the height has been changed, or it's been changed. You could also see I'm changing the cross sections. I also have different options how I can place it, or I also have different options how I can set the setting. So this is what we're referring to. This is a component or an object, which is a parametric in a sense. And I'm going to use it because I will store it in a proper library. So I will use it in a different project as well. So I have created this bearing. I will use it multiple times in this project, and I can use it also in another project. A new feature, or to leak something to you, because we'll release a new version of Allplan in October. So a new feature that we already have is this is Allplan Bridge. So in Allplan Bridge, what is possible is you can visualize the Python parts or these components that I'm referring to. So you can visualize them in Allplan Bridge separately. So you can see if they are placed or if they look according to the required specification. So that's a new feature that will be released. So besides library objects, we also have reinforcement. So reinforcement is a really interesting topic, and it could also be a tiresome topic because detailing takes a lot of time and a lot of energy. But the idea here is we can create them in a parametric way, so we can fit them in different use cases. Before I show you what I mean by parametric reinforcement, just to give you an idea how it's possible to create a parametric reinforcement. So in a sense, this parametric reinforcement, they are also objectives similar to the bearing that I have showed in the previous slides. So they are all called Python part. They are parametric objectives. So you can also create this Python part using 2 ways. One is you can use a visual script. It's a way of programming. You could also use a Python script. Basically, they both are the same thing. The visual script, you don't write lines of codes, but rather you have nodes, which are by themselves lines of codes, and you just connect these different nodes. So it's really interesting. I will explain also later what visual scripting is. In the Python script, we have an Altplan API, so you can also access it. It has already good documentation, so you can use this documentation to create your Python script. So, but the idea is you use either Visual Script or Python script to create this Python part or this parametric object. So we use the same concept to also create a parametric reinforcement. To give you or to show you what I mean by parametric reinforcement, let's say we have here, as you can see, a foundation reinforcement. As you can see, we have also the properties or the inputs. So I was able to change the lengths and the widths easily. I also have the properties of the reinforcement. Here, as you can see, I have a spacing. I could also change the bar diameter, the steel grade, or different properties. So this is what we are referring to a parametric. So you have this foundation or this reinforcement, and you can use it in different way or in different cases as well. So that's what parametric means here, or what it's referring to. So the idea is we have already this parametric reinforcement and we can place them. Of course, you can just create it and place them in Altplan or in Altplan Engineering where you need it. Or we also have this really cool feature that is you can place these parametric objects or parametric reinforcements while you are creating the cross-section of your bridge. In this case, for example, we have an abutment. This is an Altplan bridge. Like I said before, in Altplan bridge, we have an axis, we create then the cross-section. So when we create this cross-section for the abutment, what we can do is we can also place the reinforcement or the parametric object. So here, as you can see in the red symbol, I've placed this reinforcement. I have also the possibility to set the values of the reinforcement. So I can set the value so that this reinforcement would adapt to the cross-section. So if the cross-section changes, this reinforcement would also adapt. Because we've seen that the reinforcement is parametric, so it's possible to change the lengths, the widths, but rather than changing it manually, what you can do is we can set the values of these variables or inputs to be the same as the values of the cross-section. So it means the reinforcement will adapt to the cross-section. So that's really good feature. Of course, there are also options that will allow you to rotate it, place it in a different orientation or in different way. So here, as you can see, I have placed it in the cross-section. I didn't place it in the 3D, I just placed it in the cross-section while I was creating the abutment. And you can see the reinforcement has been placed accordingly. So the idea here is if I change the cross-section or even if I move the axis of my bridge, the reinforcement will also move accordingly. So the reinforcement adapts to the cross-section and the cross-section adapts to the axis. So everything is interconnected, so it makes it easier to introduce change. Besides reinforcement or besides the visual script for creating reinforcement, we can also use a visual script to automate some tasks. Before I show you that automating a task, just to give you also a simple or a little introduction to the visual script. So like I tried to explain before, visual script is, or visual programming is a way of programming, but instead of using lines of code, you just have a graphical way or a graphical nodes that you can use them to do some tasks. So here we use visual script for different purposes. One of which is the automation, but there are also other advantages or uses, such as we can use the visual script to create forms. So here what I mean by forms is you have seen the forms for the parametric reinforcement where we have different inputs for the parametric reinforcement like the steel grade, the spacing, the lengths, the widths of the object. So these are all forms. So you could also create this using the visual script. Or you could also use visual script to analyze your bridge data. So now we are moving to the model-based and also data-based or generally BIM workflows. So we are enriching our model with information. So this information will be used, right? So to use this information or to analyze this data, you can use Visual Script. So you can use Visual Script to maybe, I don't know, to count the number of elements or to do some change to some specific elements. So you can use Visual Script. It's also possible to create reports or even do some quantity works or different things using Visual Script. So it's really a powerful tool. But in our case, what we want to use Visual Script, or in this case, is to use it to automate some tasks. So here I'm going to give you a simple example. I'm just going to start with the Visual Script, so to show you what I mean by Visual Script. So this, the one that I dragged and dropped, is called node. So it has an input and output, so I can connect it to different nodes as well. But the idea here is inside this node there are lines of code, or each node does a specific function. So the idea is I create different nodes that do different functions and I connect them, and finally I will be able to come up with a task or with an object or with different things. Here in our case, what I'm trying to do is first I'm trying to create a line. After that, I'm trying to create a perpendicular boxes to this line, and from these perpendicular boxes, I'm trying to generate sections and section views, and these section views will also be placed finally in a drawing number. So that's the idea of this Visual Script. Of course, like I said before, we should always think of this library-based thinking, which is always the things you create, you should properly place them. So in our case, this Visual Script, I was able to save it in the office, so now I can come to the office and I can access it. So this is the Visual Script, it's already running. So here, as you can see, it's already promoted me to draw the line. So here I am drawing the line which goes along the main axis of the bridge, and based on that line a rectangular red box has been created which has different inputs, so I have changed those as well. And finally I run the script and I was able to generate section views. And the idea here is it's not just, it doesn't stop in the creation of the section views, but it also allows you to place them in the right drawing file. So as you can see, I'm turning on and off different drawing files, and you can see I have different section views which are in the different locations of the bridge. So I was able to create 8 section views and place them in 8 different drawings with just one single script. So that's the power or the automation of tasks using Visual Script. So implementing this would allow you to be much more efficient in your workflow. So this is the idea of automation. But of course you could also use Visual Script other use cases. But using this Visual Script or the information, it doesn't make sense if you don't have the right information in the object. So that's why we are talking about attributing. So attributing here, before I explain it, just to give you a little recap, we say BIM, BIM stands for Building, Information and Modeling. So here we are referring the M or the modeling to the geometrical content of the project. So we have this geometrical, as you can see, the slide, it's the model. And for example, if I click on one of the piles, I have these different properties in Allplan. And this attributes group is called, or it contains the information about this pile. For example, I have the pile which has a material something something, which has area something something, which has a volume something something. So all these are information about this pile. So this is what we're referring by BIM. So it should not always be the model or the 3D model, but we should also attach information to it. And the idea of attributing is adding a container of information. For example, this material, it contains the material type or the material something. So the material is an attribute of the pile. the area is an attribute of the pile. So that's what we mean. Attributing, we are referring to adding a container of information. So this container of information will contain information when we assign it. Of course, you could assign the attributes from BIM Bridge directly. So this is BIM Bridge. So this is where we were creating the cross sections. So while you were creating the cross section, you can assign the FC type. You could also add materials in the girders. So you can do different assigning of attribute in BIM Bridge. And you can send this data back to Altplan Engineering. So in Altplan Engineering, if you want, you can override these attributes or the values of attributes, or you could also add your own attributes. So this is in Altplan Engineering that I'm trying to add attributes. So as you can see, I have different options for adding, or different groups of attributes that I can choose from, or I could also define my own attribute. As you can see, I'm defining a pile number as an attribute, and I will add it to my pile. So here, as you can see, I have a user defined attribute group, which is already on the red box, and I have added two attributes, a pile number and the unit cost. These two will contain information. The pile number will contain a number, which is like the first pile number, the second, something like that. And the unit cost will also contain the amount of in money or in euro or in dollar. So it will contain also a cost. So these two are containers of information that I have added to my object, or to the pile in this case. And once you already create these attributes, you can easily transfer them to the other attributes. So you don't have to create them for each attribute. And you can do this using the action bar. There is a transfer attributes here, as you can see, and we have all these options. And one really cool feature here is that you could save the settings. For example, in this case, I have only selected a pile number and the unit cost. I can save this setting or this option and save it and use it later in a different project. For example, if I have a pile and this pile has different specification or different attributes that I must use, so maybe I might have 100 attributes. So it doesn't make sense to create these 100 attributes every time I have a project. But rather, I will create these 100 attributes and set them or give them some value, because maybe it's a pile, so the pile have a specific material type or something. And all the 100 attributes can be saved and you can use them. You can use them in different projects. In our case, we have these two attributes. I'm going to save them and I can access them and use them in a different project. Of course, there is a use case to all this, to the attributing, one of which is a filtering. So this might look a simple thing, but sometimes you might have a really complicated and really big project, so it becomes harder to select a few elements or a few objects. In our case, I want to select the first piles of each pair, because I already have an attribute called pile number, which has a number of each piles, and I already know that each pile, or the first pile, is numbered 1, 11, and 21, so I can filter them using that, and I can just select the first piles. So this is one use case. Another use case is cost estimation. So we can use also attributing to have a preliminary cost estimation. To do that, I have two steps that I used in this case. The first one is I created a legend, or I defined a legend. So it's also possible to define a legend or your own legend. You can create it you can get it in the user defined action bar. So I have created the legend. As you can see, this is the legend that I want to have for this project. And of course, the second step is to have the required attributes. So for this legend, I need a material, I need a name, I need a unit cost, I need a volume. So all these are required for this legend to work. So I should add these attributes. Then finally, it works. To show or to demonstrate what I am referring to, as you can see, I have the same bridge project, and this is the reinforcement, the pile reinforcement, as you can see here. And this is just to show you there's a reinforcement inside. But the idea here is I will go and I will open the legend that I want to use. Here to notice is that it's placed in the right library as well. So legends could also be saved in different library. So here I have the cost estimation. As you can see, I have the name, the material, the unit cost, the volume, or the pieces as well, and the cost for each object. As you can see, we have the pile, which have different pile numbers, different material types. Of course, they have different volumes as well. Finally, I'll have a total cost. Because I have only added a unit cost to only one of the piles from the old project, the pile number 05. Because here, as you can see, I have a unit cost of 100, so it was multiplied by the volume, so I was able to have a cost, which is the total cost. So the idea here is, what if I make change? Because we are in an industry that frequently changes different things. So here I have changed the radius from 0.9 to 0.7. One thing to notice here is that I have also the parametric reinforcement here as well. So this is the reinforcement. As you can see, I have set the radius and the height of the reinforcement, so it would adapt the cross section. So I will update it, and as you can see, after I update it, the volume has been changed. It was 25 point something, and now it's already 15 point something. So if the volume is changed, the unit cost will be multiplied by this changed volume, so the total cost will also adapt. So that's the cost estimation. And the really cool feature is that if I change the radius, like I said, the reinforcement will also change. So as you can see, the reinforcement has also adapted to this use case. So this is another use case. And the third use case would also be for construction or maintenance or management. So I have this bridge bearing and I have different attributes, but in our case I have a default attribute from Allplan. It's called the mark number. So I can use this mark number and I can set a value for each bearing, a value. So if I have this value, and it makes it easier to place which bearing and where, because we might have a different specification or size. And if I already know the number of the bearing, and I will just place them where they are required. So it makes it easier in the construction phase. Even after the construction is done, we want to manage the bridge or we want to do maintenance. So in this case, it also makes sense to go and to just take the mark number of the bearing and go and do a site visit or even manage it from the office. So it gives you an added feature. So this is what I was referring to, the creativity in the beginning of the slide. So this is also an added advantage. Finally, it doesn't make sense to talk about BIM and not talk about IFC. So to show you what is also possible in with Allplan, or how you can export your bridge and an IFC, just to give you a glimpse. So here, as you can see, we have the same bridge and we have the precast BIM, as you can see here. So we can define the IFC type, and the material is also included. And the thing you don't see most is it's also possible to send IFC tendon. So the tendon material is also, the tendon is also exported as an IFC data. And of course, we have also the pile, which have also my own pile attributes that I have defined, the pile number and the unit cost. So it's not always about IFC attributes, but I can also export my own attributes. Here you could also see it's possible, or it was easier to export the reinforcement as well as IFC reinforcement. The material is also included, so you could export the IFC. And this is also a new feature or a leak that we are going to support, or we already are going to release a version that supports IFC 4.3. So this is a really good advancement for the infrastructure area, because 4.2 is for bridges and 4.3 supports rails, and so it makes it really powerful in terms of the collaboration. So this IFC 4.3 is meant for the bridges, so this would also be released in October, or in the new version. So thank you. This is all from my side. Hopefully you enjoyed the webinar, and if you have a question or if you want to contact us using the emails which are available in the slide, or you could also go to allplan.com and you can have access to the product. So thank you everybody for coming. Have a nice day. Ciao.